Welcome to solverfy.
Okay, so in this question, we have a continuous chain of resistance, right? And that resemble to figure 26.83 in the book. Now, in this question, we have to show that VCD is equal to VAB times 1 plus beta, where beta equals to 2R1 this one. And in this RT is the total resistance across A and B, that is R1 plus R1 square plus 2R1 R2. So to do this, what I would begin with is, but if you look at the figure, then VCD, voltage across CD, should be resistance across CD, because RCD, RAV are in series, because the resistance RAC, RCD, and RVD are in series, right? Remember that as a small d. Okay, so since they are in series, so the potential gets divided proportionally, so this much into the total resistance, that is VAV, the total voltage, that is VAV. Now what is RCD? So the resistance across CD is actually R2 parallel RT, right? And resistance across AC is R1, BD is R1, so I can write twice R1 plus the resistance across CD is again R2 parallel RT. This much into VAV. Okay, now since we need VAV in the numerator, let me write VAV in the numerator and keep everything else in the denominator. So in denominator I will have twice R1 plus, so R2 parallel R1, sorry, R2 parallel RT upon R2 parallel RT, isn't it? So from this you can write from the second term in denominator, it turns out to be 1, right, plus twice R1 upon R2 parallel RT. Now what is R2 parallel RT? R2 parallel RT is simply R2 plus RT and upon, since this is division, so R2 parallel RT will make it reciprocal, so RT times R2. Well, if you look this, so this should be V, right? So hence, so this implies VCD equals to VAB upon 1 plus beta, right? So you prove this. This is part A of the question, right? Now in part B, what is required? Okay, so it says that VAV equals to V naught in part B. The question so says that VAV equals to V naught, right? Now for n segments from left end is Vn. Okay, well, so in that case we have to find out V for nth segment, right? So for the 0th segment, V is 0 V naught. So for the first segment we found out BCD is equal to V1 is equal to how much? V0 upon 1 plus beta, right? Now if you look at the second segment, so b2 should be surely obviously equal to b1 upon 1 plus beta, and so on, right? Now what is b1? B1 is again b naught, so this should be v naught upon 1 plus beta power 2, right? So look here. Now the subscript here and here, the power in 1 plus beta matches, right? So if you carry on, then you get Vn equals to V naught upon 1 plus beta power n. Okay, so this is this is shown, that is also asked in part B of the question to show this. Now it says that if R1 equals to R2, well, so if R1 equal to R2, how many seconds are needed to decrease the potential difference Vn to less than 1% of V naught? So what we want is, let me write that in the second page. What we want is, condition is Vn should be less than 0.01 because it is 1% of V naught, right? So what is Vn? That is 1 upon 1 plus beta powered n should be less than 0.01. Well, to calculate the value of n, it seems like we have to first calculate beta. Now to calculate beta, we need to calculate RT. So see, using RT equals to R1 plus root under 3 R1, which equals to R1 times 1 plus root 3, right? So I calculated RT. Similarly, beta equals to, considering R1 equal to RT, okay? Consider R1 equals to R2. So I replaced R2 with R1 for the expression of RT. Similarly for beta, this would be 2 times R1 times R1. So that will be 2 plus root 3 because we have to add R1 in RT. So 1 plus root 3 would be 2 plus root 3 upon, this is R1 squared times 1 plus root 3. This turns out to be 2.73. So it seems like 1 upon 1 plus 2.73 powered n should be less than 0.01. So this gives me n should be approximately greater than 3.49. So the next one that is greater than 3.49 means n equal to 4. So there should be 4 segments, so that the V is V and V4 is 1% of V naught. Alright, so we are done with part B of the question. Now let's move on to part C. Well, in part C, given that del x equals to 10 to the power minus 6 meters. I don't know if we need this. Let me write it, whatever it is given. So, and it is given that R1 equals to 6.4 into 10 to the power 3 ohms, and given that R2 equals to 8 into 10 to the power 8 ohms, right? So first let us calculate RT. So using the formula, RT equals to R1 plus root under R1 square plus 2 R1 R2 This gives me RT equals to 3.21 into 10 to the power 6 ohm. Okay. Similarly, to calculate beta, we get beta equals to 2 times R1 times RT plus R2 upon RT R2, right? So this gives me beta equals to 4 into 10 to the power minus 3. We are done. We are done calculating RT and beta. Now for D, it is given that the length of the axon is 2 millimeters. So the number of segments there will be L upon del x. So L is 2 millimeter, del x is 10 to the power minus 6. So this gives me N equals to 2000, right? So V 2000 upon V naught, that is what the question wanted us to calculate, will be equal to 1 upon 1 plus beta times 2000, right? Now we calculated beta to be 4 into 10 to the power minus 3. Just plug this in here. So this gives me 3.4 into 10 to the power minus 4. Wow. The voltage decreases very sharply in the 2000 segment. That is by 3.4 into 10 to the power minus 4. Isn't it? Okay. Now for part E of the question, says that there is a coating that increases the resistance of R2, and R2, let me call that R2 prime to be 3.3 into 10 to the power 12 ohms, and this also changes the RT prime equals to, again using the formula, R1 plus root under R1 squared plus 2R1 R2 prime. This turns out to be 2.055 into 10 to the power 8 ohms. Alright. Similarly, the value of new beta prime, let us consider, will be equal to, using the formula, 2R1 RT prime plus R2 prime upon RT prime R2 prime, which turns out to be 6.22 into 10 to the power minus 5. Okay, so the attenuation would be, to calculate the attenuation, V2000 upon V naught is equal to 1 upon 1 plus 6.22 into 10 to the power minus 5 powered 2000, which turns out to be 0.88, right? So the attenuation is smaller now. There is like comparatively less decrease in the voltage, right? So this smaller attenuation causes increased propagation of signal. So with this, we are at the end of the solution to this question. Thank you so much for watching.